Recording, so we will.
Yep.
Good evening, everybody, and welcome to this presentation. No matter where you're joining us from, we want to welcome you, and we're happy that you're going to spend the next hour with us learning about this machine learning industry. And it is booming. The market is in a perfect condition, so it's never been a better time to seize this opportunity and learn more and to possibly become machine learning engineer. Tonight, I'm going to have two my favorite experts who will be sharing the insights about this career path. And before we get started, feel free to uh, text in the chat. And if for some reason you missed the beginning, or if you would like to share this presentation with one of your friends, so you're more than welcome to do so. So let's dive in, and I'll give a small overview of our school. And we call our bootcamp Black Screen AI. And so it's a project of the PAS IT School, which was started in California in 2016. And we had so much success. Actually, originally, we launched this school for the Russian speaking or Slavic speaking people who wasn't even native speakers. And we had so much success. So we were able to help over 35,000 students to get the job. And then we decided, why don't we open this opportunity for English speakers as well? And since 2016, we're very fortunate. We were able to help people to get this career path. And we helped over 25,000 students all over the world to get into IT world. And right now they have their dream lifestyle and flexibility, which I believe IT field provides. And so we have instructors who work in the industry that would puts us apart any other school out there. It's very important because the industry is developing so rapidly. So you have to know the latest knowledge, and we're famous for it. So I'm very excited to share with you a few pictures of our graduates. You can see those happy smiles, and I'm just so excited, that we were able to help them to change their lifestyle and create the career path and lifestyle they deserve. Especially during the COVID, flexibility became a priority, and we were able to help a lot of students to have the career path in IT world and become successful in it. So if you would like to learn more about us, you can check our YouTube channel. There are a lot of testimonials, and I'm looking forward to new testimonials all the time. So who knows, maybe your story would be our next testimony, and you will find your dream career in IT path, and we would be happy to help you. And our students, they work in pretty much any company, you name it. And we're very proud of them. And I hope that you will become one of our students. And so stay with us till the end of this presentation. For everyone who stays till the end, we prepared some bonuses and surprises. And I can't wait to introduce you our experts tonight. And actually, I'll let them to share about themselves. But I would like to introduce you, Mr. Paul Colhoun and Alexei Pasenchuk. And I can't wait to learn from them together with you. And I will be monitoring the chat. And in the end, we'll be able to answer your questions. Hopefully, we will have enough time. But welcome, everyone. And I can't wait to see and learn together with you. So, Alexei and Paul, you take it from here. I'm so happy that you found time to share your knowledge and how you got into this field, how you became experts, and now we can learn from you. So welcome.
I'll go first. So
Go ahead, Paul.
I'm Paul Calhoun. I'm currently definitely an MLOps engineer, or I manage a group of MLOps engineers for a Web3 startup. And uh, officially, my title actually there is ML machine learning architect. So but um, the sort of requirements are they involve taking large amounts of data and condensing them into sort of useful objects in this case that can be represented on some sort of compute somewhere. So be that many, many computers or just a single one locally. Um, the last place I was working full time was Blue Box, where I did a lot of edge, so like machine learning plus Raspberry Pi size sort of Arduino as well. Scale stuff for access control of buildings. So it was biometric scanners, various dealing with the interfacing with the various companies that do uh, uh, different layers of or levels of security and access control for buildings. So there's a lot of big products out there. Few of them have started to integrate AI, just visual recognition type tools, stuff like that. In like a NVR, which would be network video recorder, that'd be the sort of service where you'd right away you could see a machine learning component. Recognizing faces is another one you can use. Local models running on basically a little Raspberry Pi, a very small computer that does machine learning stuff. And it was called a Jetson Nano. Some of you might be familiar with it, but yeah. And then before that, I did work with GPT-3 when it was the GPT-3 API was really the only or the biggest language model in town. So that was like 2021, 2022. And uh, I fine-tuned a couple of the GPT style models when they first came out, more in a sort of hobby testing out sort of capacity. And then later I got to fine tune some models for cloud use in this case. They could have run locally. They were small enough, but they're language models to basically run chatbots for in this case it was a customer service example that was at Blue Box. So they had language models and they had face recognition biometrics component that they've been working with for a while. All right, cool.
That's awesome.
Thank
So
you,
you're
Paul.
truly expert. When our students join our school, you would be able to share some insights because it's not your first time teaching. So we're excited to have you tonight. Alexei, can you please share a few words about your favorite path?
Welcome everybody. My favorite what? My favorite path?
Your favorite
Pet?
path in IT world, you know? So you're a
Oh,
DevOps engineer, and so what's your favorite part about it, and how many years you got in the industry? Just to encourage
yes.
people that anyone can get started. They just need to put effort in it.
Let's start with the answer. Everything is my favorite. I really admire DevOps and the way how it's transforming everything. I'm professional DevOps engineer. I started my career sometime around 6-7 years ago. It's hard to count by now. I also went through the PSV slash Black Screen Bootcamp at that time. And basically they gave a boost to my career. And later, 3 years, returning back to the PSV, we decided that I can share the knowledge which I gathered myself in my professional field and actually create the bootcamp on the based on the PSV. So I'm not new here. I'm teaching DevOps course here. I'm doing DevOps for 6+ years already. And I have under my tool belt, I have a lot of interesting companies. I switched my job, I think 3 or 4 times in this field, and currently I'm employed by one of the really booming company. It's Life360 if you're curious, and this company should be very familiar to you if you are living in the United States because it's the family tracking app. So it helps the family stay connected and understand where everybody is at any given moment of time. And it also provides a peace of mind that you actually know where your loved ones and what they're doing in the moment. Not that
Right.
you cannot disable it by the will. Yes, I've done a lot of interesting things along the way, and currently I'm partnering with Paul on this webinar because I really do have experience launching the large language models on the hardware on site. I do have my own small home lab and also in the cloud. And I think the MLOps is the next future development coming off the DevOps discipline. Sorry, Paul, if I'm stepping on your toes here. And yes, basically, without understanding of the cloud and the way how it works, you need to have at least basic understanding. So I will be mostly helping Paul here to lead the webinars. So I'm not the main host here. Paul is the main host. But if you have any DevOps questions, feel free to drop them in the chat. So let's go. Julia. Next one. I think we're gonna switch to Paul here. So Paul, I'm transferring microphone to you.
Alrighty. What is a machine learning engineer? So, designing, building, and deploying machine learning models. Yeah, basically, as I described before, there's these very useful objects that exist or can exist on computers and be deployed on them. And they, as of very recently, in the past 3 years at this point, they just exploded in usefulness and popularity, partly because of a matter of scale. We just have enough hardware now. So they bridge the gap between data science and software engineering. Well, that's an excellent way to put it. Sorry, can you tell I didn't make this particular slide?
That's okay. It's always the case, so that's normal. You guys can expect some bloopers along the way here for sure.
Yeah. So
You'll share with us some great examples later on. And so like what I like about this industry is that our experts and instructors, they make it very interactive. So it's not just theoretical part, but because they work in the industry, they can bring practical part of it. And so I can't wait for Paul to show you some examples.
We will be changing the mold all the time, so don't worry. Sorry, Paul, I think you can continue.
Yeah, this one, I think the gap between data science and software engineering will be elaborated on further in one of the next slides, if I recall correctly, when I skimmed some of the ones that were, yeah. Oh, this is more about the course. And
yeah,
so,
I think so.
All right.
Do you want me to take over?
Sure, if you want to go over this part. Yeah.
Yeah, I think so, I should. So basically, Julia, can you go back one slide more? Yeah, so no, forward. One more. Okay, here we go, guys. So there is about the course itself. Let's start from that part. The course itself consists of two parts. One is the pre-requiree, something what you need to meet, right? Because you need to have a basic understanding of the Python and be able to work with the actual coding part. And if you don't, we do have the Python intro. It's an 8-week course which will introduce you to the basic concepts, and it will familiarize you with the syntax, and it will help you to start solving tasks based on the algorithms. Without understanding of the Python, the machine learning will be very difficult to start from scratch. And if you do not have that knowledge, the Python is highly recommended. I'm not saying it's not possible. The thing is that we're trying to make your life easier, and that's how we pre-plan the course, right? So first 8 weeks, definitely plan on spending, getting familiar with the Python, start to work with the coding, and start to work with the actual algorithmic structures. Again, you do not need to be professional coder or like developer, right? But it's still required. So the next slide, please.
And I also wanted to
Yes.
sorry, Alexei, that for everyone who stays with us till the end, we do have a special promotion for those who don't have a knowledge of Python and they want to learn. So we prepared something special for those who are particularly at this webinar.
Okay. With that out of the way, the second part, if you already possess the knowledge of the Python, you are great with it, you already have the basic knowledge, you are fine with the algorithm functions and objective-oriented programming paradigms, then you can diving into the ML. The thing is that it not necessarily needs to be a Python, but if you know JavaScript or Java or even scripting languages, it will definitely help. So maybe you can skip the Python part, like at least half of it. Again, talking from personal experience. Now, what are the key roles in the machine learning, right? That's something where I will ask Paul questions because, hey, I'm a DevOps engineer, not ML engineer yet, but we'll see where it leads us. Machine learning versus data scientists, right? So machine learning is focused mostly on implementing and optimizing models for production use. And that means that machine learning engineer is focused on the creating the structure which can be used in the production, and it also can be scalable, and it also can be deployed properly, and it's also performant, because basically the more hardware we need behind, the more expensive is the machine learning, the actual model is for us. I'm not saying LLM, it's the wider host of the models. Data scientists, on the other side, is focusing more on the actual data, which is getting fed into the machine, and the data which it needs to be formatted in the certain patterns, the data which is need to be supplied in the certain patterns as well. And data scientists are more focused on the actual data and how it helps us to create the model, like
Yeah, the word model there is
Thanks.
subtly different between the two, ML engineers and data scientists. I mean, there's big overlap, and modeling something can involve prediction, but there's just typically much more empiricism, I guess, or you're going at it, you're building a foundation in something with a data scientist model. They're doing some sort of like, regression or something. They got there's all sorts of, like, they call it fintech, financial technology. There's all sorts of uh, predictive models out there that people have used when computing was very limited. These are the only models available. And what we found is that, and this sort of took over machine learning very, very recently. In the past few decades, it's become completely apparent. In, I would say, the past 1 decade, it's become unambiguous. So 2015, 16, 17 was right when it transitioned. But this has been around for many decades. It's just we didn't have the technology to really scale it up enough to make it clear that this, it's called the perceptron. It's basically a biological neuron sort of analog that you're running on a computer. It has a firing potential and it's connected to other neurons with little things, effectively dendrites, the same sort of deal. That's called the perceptron. Someone just won, was the guy who invented the perceptron won the Nobel Prize? Geoffrey Hinton won for his work recently with neural networks. Now I'm getting into the weeds, but basically neural networks have taken over machine learning. And you could think of them as a massively compressed data set using this one particular algorithm arranged in different structures, and then shown many, many examples of what a data scientist would typically analyze. So those are those two fields sort of compared right now. Sorry, go ahead.
Okay. Yeah, let's go for the second one. Difference between machine learning engineers versus software engineers. And this example is more distinct because software engineer is focused on the wider application of the knowledge and wider system overall, because software engineer is focused on the developing the actual software which can run the language model, for example. But language model can be just a part of the software. So software engineer looks into the broader picture, and they need to understand more parts of the system and how they interact together. So they are also focused on the architecture and code efficiency and user experience, of course. Machine learning engineers on the other side, they do focus on the narrower, so the scope is actually narrower, and they tend to dive deeper into the actual models itself. So something what can be used for the software system, which can provide a certain functionality. Also, data pipelines and real-time processing. Yeah, that's a cool part, actually. There's a lot of cool stuff today mentioned today. So I highly suggest you guys take notes of something what you didn't understand or something what looks kind of really blurry, and you definitely can either ask the follow-up questions to our sales guys or you can just have a channel of contact with us and we can explain things. Anyways, ML engineer is more focused on the actual language models or an actual implementation of the model and artificial intelligence into the application. So software engineer gives us the whole thing. We work on the part of it, but we enhance the functionality of the application. I think you all seeing lately, for example, like Google implemented their Gemini into the Gmail app, or they replaced the Hey Google stuff. Hopefully I didn't activate anybody's phone now. With the, again, Gemini Assistant, that's how they call it. So the Gemini Assistant itself is the probably partially or like 80% ML engineer work because they developed the model, they help to integrate it. And the assistant, which is exposed through our microphone in our cell phone, is the actual software engineer work. I think we can go to the next slide. From there, I'm gonna transfer microphone again to Paul, and he probably gonna treat you to couple on of the facts and knowledge, certain knowledge.
I was
Yeah.
gonna cut from here just to say that that top layer is what's called a convolutional neural network.
Mm-hmm.
And I just wanted to demonstrate a very simple example of a convolutional neural network, just to give people, just to disabuse you of the notion that this is like a programmed piece of software.
Okay.
Because it's handled by programmed pieces of software, but the learning that it did was something that happened on its own. It was just shown lots and lots of examples of something, and from that, the examples were already categorized by people using our neural nets. And so that's how you get tagged data. And so if you switch over the screen share, actually, you just
Yeah,
have to
okay.
turn that up.
Yeah, I'm gonna stop Julia's share, and now it's your turn.
Here we go. Great. So what we've got here, and I'll drop this in the chat in just a moment, but this, don't be daunted. I'm not going to try to explain every component of this, but basically there's a relationship between the different layers of this neural network as it's sort of in this Minecraft format. There's a relationship between a few of them. So these are convolution layer 2 is the one that's going away, where it's called a convolution, where you're taking it's just in math, it's just mapping from two functions into a third space. But yeah, but in this case, there's a matrix algebra component. It draws on a couple different prior layers, and also a wider region of, you'll notice there's like one component here. So basically, just to give you an idea of what this thing actually does, let's see, where's the numbers? There are the numbers up there. So that's the end of the neural net. The beginning down here is this space that I'm about to draw on. So if I put just sort of a line, yeah, it probably guesses 1. Yeah, first guess is 1. So that you can track backwards from, these are called, let's see, these are input layer. Yeah, there's a convolution layer 1. So take some subset, and then, oh, downsampling, just, it's where you're, yeah, where's downsampling? Oh, I see. Okay, because that one's input. That sounds like none of these are lining up. But basically, if I finish this, ta-da! It goes straight to 6. Boom, 100%, or very, very likely a 6. Not likely to be a 5. I think all of our neural nets agree on that. But how did it get there? You can see, and I promise I will share this. You can all load it in your browser. You can see what you get, what sort of is drawn out at each layer, where it's a convolution, versus downsampling, where it's representing in one sort of pixel, you could say, but by then it's kind of abstracted from the concept of pixel. It's representing something larger. All of these are packaged up very nicely inside of Python. And the way that we will be handling most of them in the course is wrapped up nicely in Python, running on a GPU very quickly. However, it is important to just see the origins of things. That's just to get a good grip on like what you're actually dealing with. So if I, erase some stuff here, can turn this into a sort of a 5, right?
But not
Yeah.
completely 5.
And now it's a 5.
What is the probability factor here? I'm just wondering.
Yeah, you can see here, I can just do it by clicking. Oh, wow.
Oh, okay,
It
here
straight
we
up
go.
went to, yeah, I think there's a softmax layer on this, although to be completely honest, this is a more simplified convolution. It's not one that I would know in particular what's being done at each layer. I can tell you that, for example, convolutions mapping over from one function to another. But if you can see that, for example, not all of the prior bigger layers are attached. So that's one, you could sort of suss out. You can also represent in so another famous convolutional neural network was called Deep Dream. And this one was back in 2014. So you can see it's sort of the ramp up to like, oh my gosh, these things are very useful. Like when Siri got good at voice recognition. And what Deep Dream would be trained on is recognizing a particular thing. It would be shown images that were the thing or were not the thing, and it would assign, it'd get one probability of 100% on the thing, the pre-tagged images. And what you'd get is if you ran it in basically in reverse, is it was just trained on dogs, it would turn everything into dogs. So there's a little more to it, but that's basically what's going on. It's kind of horrifying in this case, but yeah. So I will drop that image in there, and then you can continue the slideshow for now, and we'll just come back to me later.
Okay.
How do I? Oh yeah, stop share.
Okay, Julia, I think you're gonna share again.
Right, we'll continue with the slides. That was very impressive.
Yep.
Thank you, Paul. I was very impressed. I love that example. And I posted in chat. So if you stay with us till the end, you'll get a chance to learn not just how to do it, but many more other things at our course. And I'll let you know how you can get started. So stay tuned.
Okay, next slide.
Right. Oops.
Yes, this one. So Paul, it's still for you, I guess.
Tell us more, Paul.
Yeah. Did we lost him?
Oh, you're
he's
muted. Just unmute yourself. Mhm.
Sorry about that. So the prior slide, good. Okay, there we go. So it had a recurrent neural network at the bottom. That's the RNN that's there. It's got that loop in it. So you can sort of see the historical progression of different approaches to neural networks. Exactly. Where ultimately you still have that perceptron, which is like a firing potential and a neuron. We'll go into more detail in the course. And the next one to the right of that RNN is an LSTM, long short-term memory. Funny name. You'll notice a lot of weird naming conventions. Sort of the naming, the sayability of the name is an afterthought because a lot of people are just inventing these in sort of labs and like Google and cloistered places. But anyway, the CNN is there on the right, and we can go to the next slide because the sort of features of the face in that top one are apparent from the thing I showed you before. So attention is all you need. So this is the slide, I titled it Transformers versus Everything Else. So attention is all you need is a paper, I believe it came out in like 2016 or 17, and it came out of Google. And basically, all those prior model types that were tried, and then some funny, this is a meme image I found somewhere. But
That
basically
was a good one,
attention,
actually.
yeah. Basically there were all these ways of representing, because these are now language models we're talking about. So these are text to text. Sorry if I didn't make it clear that we were moving to a different modality, as they call it.
Hmm.
But LLMs, yeah. So and I'd say I think LSTMs you could sort of call the first large language models, because some of them are represented. I even heard a podcast interview with a guy who was, they're like bringing them back at a larger scale. But these GPT style LLMs that do away with um, uh, a lot of the mechanisms for carrying along information, in text. So where in the past you had your text complete, your autocomplete on your phone. That's usually a Markovian, or it's only looking at the last few words, or maybe even just the very last word. And so it'll be nonsensical if you just pick the highest probability next token or next word every time. But because there's no coherence over a long sentence. As it turns out, if you are willing to basically cook leave the LLM in the oven for a long time and also scale it way up, you can encode the rules of language in that LLM, as long as you're showing it unique data each time. And really the only thing that LLM needs in order to represent those rules of language, including world knowledge in every case that we've seen, like LLMs, they'll just retain facts about the world and stuff, and then bring them up with high probability as subsequent next tokens. It turns out you just need to pay sparse attention to prior tokens. That's the secret sauce. That, and you could say the multi-layered perceptron. There's this big layer that no one quite explained has explained yet. But basically, transformers were the first architecture that could be scaled at the sort of costs that people, sort of a lot of factors had to meet at a sort of triple point of a lot of factors. Three at least.
Compute capacity. We had enough data. I guess they scavenged internet enough, right? For training.
There's an article somewhere. I mean, having enough data, you're right. We needed the internet to happen. But there's an article that was like, why didn't we have GPT-2, which was a fun little model to play around with. And you can, on my Deep Dream thing, if you scroll down, there's like lots of little things in there about how to use small large language models, like 0.5 billion parameter ones. But GPT-2 has been around since about 2018, publicly available. It's just so tiny. It would just be nonsensical mostly, but it was coherent enough over sentences that you could tell something was going on, something really interesting. All right, so we'll go to the next slide.
So basically, Paul is saying that current large language models are just enhanced T9 on boosters with some additions of Secret Service. I'm saying T9 from the cell phone. Like, it's a huge database of T9 enhanced on the boosters, if that makes sense.
I used to say some sort of rep T9. So, I mean, the letter T and the...
I mean, T9 is the autocomplete for the cell phone keyboard from the past.
Right. It's a gigantic T. You're right. Autocomplete T9 auto. That was the name of the. Yes, I just completely.
Great example, Alexei. I like it. So that helps me to see what it is, So that's awesome. I'm glad you made that comment.
I hope people got the reference.
Also didn't get it, and I helped them. I'll just
Yeah. No, that's correct.
I'm probably alone actually in that, but everyone else.
Yeah. Well, no, not everybody is old enough. Come on.
I was like, is it the T200, the Terminator? Is he making some Skynet thing?
That's 800.
There you go. Yeah, that's right. For some reason they gave him
let's
that
continue,
accent.
I think.
All right. So this one is basically talking about another type of language model. It's part of machine learning. It's not a mapping from text to text. It's not auto-completing. It's what this one's doing is it's going from input text, so some chunk of text like a paragraph, and the output in this case is a vector. And by vector, it's just a string of a bunch of numbers, so a list of numbers, and auto completion. A string of numbers, and it can be of a particular rank. Typically, it corresponds to sort of the dimension of this space that your neural network is sort of figuring out. So in that space, the vector corresponding to the input string Garfield, like Garfield the cat, should be somewhat close in that high dimensional space. It's not just 3 or 2 dimensions as portrayed here, but it's a very high dimensional space. It should be nearby, the sort of literal distance in that space should be low for, you know, cat that eats lasagna and is a cartoon and is orange. That sentence, while it doesn't have much overlap with Garfield, is near the word Garfield with a capital G, I suppose. So that should hopefully convey the sort of semantic. It's a little bit like the Deep Dream, you know, drawing a dog out of everything. Just turn everything in more and more dog-like. Dogs are all I know, and so because that was what the neural network was trained on. There's some distinctions to be made. I thought this one made it very clearly apparent, like clear how like pear and apple are semantically similar. And then there's a visual component. Nowadays, you can actually have multimodal embeddings, so you could have input image, and there's a couple different neural networks, some of which are basically just the eyes, the sort of visual processing component of a much bigger LLM that is repurposed for effectively getting visual embeddings that have a text component. So this is a VLM that's multimodal, that's big, and these embedding models are typically much smaller, but this one now is multimodal, just like I know this is the sort of thing that you do with ML engineering. So you learn about the parts under the hood, and then the parts under the parts under the hood, in this case, would be things written in C and C++ that I think it's just C for CUDA, is the sort of the much more efficient low-level programming that has all sorts of high-level operations. Like if you want to just have like a sine wave activation function, you'd pull it out of CUDA. You wouldn't have every part of that computed in Python because that would take forever. But when you want to just load a model up, you can do that in Python. Nobody cares. The wrapper is a tiny fraction of the overall cost sort of load on the system. You just try to avoid loops a lot beyond just the main training loop, I guess is one way to put it. And you'll be safe with Python. Okay, so we can go. So Hugging Face is, and this is actually something I just wanted to show one more time, and I'll only take like a few minutes, like 3.
Okay, so
I
again,
won't generate
transferring
anything.
share
I'll
to
just
you, right?
show you. Yeah.
Mhm.
Yep. Okay.
Cool. Sorry for the delay. There we are. All right. So it's that same one that I showed to everyone. Yeah. So this is a text completion. Oh yeah, this is GPT-2. So teensy tiny model. It's running on a GPU. It's totally overkill. Although I also ran the entire thing beforehand, and that's why the much more of the GPU is used up. So that's that. Oh yeah, here is LLMs. These ones are visualized now, and trust me, this is not something you're going to need to know directly. This is not. I'm showing that this is not like typical programming, but you'll be dealing with these objects using things like Python wrappers, in certain cases wrappers of wrappers, because the transformers module, which that's what that slide was about, basically this thing called Hugging Face, which is this it's sort of trying to be the GitHub. It's a French, I think it started as a French company, but it's based on, the name is from that emoji. But but it's trying to be the GitHub of LLMs. So this is a resource. It has all sorts of, it's a code repository and also a model repository. So the weights of the model, all those trained things in that very large structure. I'll drop this also in the, it's actually in the Colab notebook. Yeah. Okay. So just to show you GPT-3, which blew everyone's mind back in 2022, I think, late. Yeah. I mean, it was 2021.
Oh, wow. That's a scale. You
Yeah,
just keep scrolling back.
Yeah, this is GPT-3. This one was GPT-2, which is the TT Tiny model. So this just shows you why they are turning on 3 Mile Island and activating. There's an insane amount of future
Energy,
money is being
yes.
invested directly in this industry. But anyway, so so these are these art models. In this case, the examples I have here, I didn't want to take up too much compute locally, and so also the Colab instance is also remote, but and so I just demoed basically some of the API use for Hugging Face. They have all these fun little ways you can offload computational effort onto their servers. And I also fine-tune a model at a certain point down here, QN 0.5b. It just goes through like, I think it's 20 training rounds. And fine-tuning is where you can change the behavior of a model by freezing most of those layers, like the ones we saw before, freezing most of them, but keeping some of them limber enough to change when you do what's called backpropagation, which I promise we will go over to whatever degree of complexity each of you would want to hear it, because it's not core to doing machine learning. It is just the thing that all of the machine, I can say is core, but it's to doing machine or practicing machine learning. You can deal with large objects using very small Python scripts. In fact, you can even make your own Python scripts by using Code Complete. There are, and in the near future, generating a random number. So look, I'm just tab completing, and Copilot is just creating a script that will now run. I can go.
That's called dub engineering here.
Yeah.
Don't get too carried away, guys, because you do need to understand the core concepts of the OOP before you can actually do the dub engineering. Otherwise, it's very slippery slope. It's an addition from me, as again, from the guy who works in the industry, because you will end up with a spaghetti code, which might work, but it will be difficult to troubleshoot and figure out what's going on there.
Yeah. So you'd want to also ask it to make tests for you.
Yep.
So
easy.
I ended up fine-tuning a very, very small large language model to just say the word chicken, chicken, chicken over and over in honor of this paper. It was a meme many years ago when I was in college. I think it was when I was in college, but it just says chicken. That's every word in the paper. I will also post a link to this paper because it's very important.
Can it convert it back from chicken into the normal one?
No, it cannot.
I'm just curious what's written under it because it's important.
I do. I wonder what it
what's encouraging to me, like what's really encouraging to me when I'm like looking at it all is that they don't have to learn it all by themselves. Like they got someone who can teach them and help them step by step to put the right foundation and do not get lost. Like if you'll try to learn it by yourself, you'll get lost. And so that's why it's so important to have an expert instructor who already has experience and just takes you step by step through all this process. And I love it. So thank you so much for being here, and Alexei for helping us to understand this industry even better.
Here you go, Alexei. I'll give this back to you.
Okay, I think it's Julia's screen anyways. So.
Yeah, let me share the slides, and I just want to I just want to go next and show you what we prepared. And so, what you will learn during this course, Alexei, I think you can probably mention all the tools they will be learning quickly. And then I will share with you how to get started and what we prepared for those who actually came to this webinar or who you're going to share this webinar with, because we prepared something special just for you.
Okay, so as part of the course, basically the idea is that you need to understand the various machine learning algorithms, because there's not only the large language models, there are others. The language models are the most popular right now, and they are all buzz around it, but you need to be able to work with majority of them, right? So it's not the only one. Data processing techniques, so basically help you to understand the essential methods for data cleaning, transformation, and pre-processing. Essentially preparation for the models, right? So how to cook the data, how to supply it properly, how to give it properly for the model, and helps to build predictive models. So you can take pretty much any open source model and tune it to your needs. That is kind of interesting stuff here, right here, because the models come with the pretty generic setup where they are usually the experts on the certain fields, where the other areas like mathematics or something, I'm taking rough examples here, but the model might not be successful. And guys, there's more than one model. For example, ChatGPT is not the only one. There are now the model war and essentially Sonnet, Gemini. They actually released the Gemini 2.0 just couple days ago, and it's all moving with a space like a really intergalactic speed, I should say. Every day there is something new. So the idea is that you take any model, you supply it properly, you tune it properly, you get the model which suits best for your needs. That's something what will be huge in the corporate environment, because like you just need the PDF document analysis model, or you just need the model which generates the I don't know, the dashboards based off your metrics from the cloud, anything. And the last one, but not least, is the practical application. So you will be applying your theoretical knowledge on the practical tasks, ensuring that you actually going to get the hands-on experience, and you will be working with a lot of tools and exactly will understand what's required from the ML engineer. Okay, next slide.
That's great. Thank you so much for explaining it, Alexei. And in the next slide, I want to answer this question: who can become an machine learning engineer? That's a great question. So as we discussed before, we showed you just like the top of the iceberg, and but it's important to have a knowledge of Python programming language, and we'll give you this ability to learn it. And if you already have it, then you don't need to learn it. You dive through machine learning straight away. And but I wanted to show you this slide because I like this career path, because you can learn this industry, and the starting salary is from $110,000 a year, which is great considering the flexibility you get. And so for everyone who joins us today, we did prepare a special offer, but I wanted to show the statistics. And the most amazing thing, which blows my mind, is that the predictions for 2030 for machine learning engineering industry is that it's going to be over $200 billion. Right now, the latest statistics I checked in 2021, it was about 8 billion. So right now it's a little bit more, but by 2030, the predictions, it's going to be over $230 billion. So it's never been a better time to get into the industry, to become an expert, and we will help you step by step how to build the foundation and how to learn it. If you need the Python, we'll help you to start there. But you have to take an action and get started, actually, because the more you delay, then more you miss this opportunity to get started. And the market is going to be overloaded with professionals, let's say a year down the road. But right now it's perfect timing. And so I would encourage you, do not wait till tomorrow and get started with us right now. We're starting a new group actually this week. So jump on board and let us help you to achieve your dream career. We do have a system in place. And so we don't just help you to get the knowledge. As I mentioned before, we have interactive part of the course. We help you with your resume, with your career, with job search, pretty much everything you need to be successful, where you didn't just finish some type of course, but we take you step by step, and we don't just give you the knowledge and practical skill set, but we also help you with simple things like resume or building your LinkedIn profile, so you would feel confident like passing the interview and actually not just getting the job but keeping this job. And so we do include internship. We have career coaching, and we'll help you to get started and be successful. We do have a training program and everything what's included. And so if you would like to know every single detail, we would be happy to share with you the full curriculum, and I'll tell you how to get it. So for everyone who stayed with us today, we did prepare, as I mentioned, a special offer. Usually this program costs $11,999, and it's not bad considering that your start salary is over $100,000 a year, and you don't have to spend over 4 years in a college where you pay at least 100 grand a year for your tuition, and then you have a student loan. So you can get started as low as $6,999 today. And I got another bonus for everyone who stayed till the end. So you can get started at this price, and then when you get the job, you can pay the rest. Also, if you don't know the Python knowledge, usually this course is $2,000, but today, for those who watches this webinar, you can get started for $999, and we have a limited space available for that, but you can join and get started. So here's the QR code. I want you to scan it. You can book your spot. As I mentioned, we do have a limited amount, because what makes us different from any other school out there is that we don't only have professional experts who work in the industry, but we also have a small group of students. So it's not going to be like 100 students and one professor, and you get lost. You don't even have a chance to ask the questions. Our groups are no more than 15, 20 students. And in this case, we know that each student, step by step, they get the knowledge, and like those models Paul was showing, like chicken, 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 you don't feel like chicken, chicken, chicken. You'll feel confident because he'll take you step by step, and he will show you how to become a professional, how to become expert, how to become machine learning engineer, and taking advantage of this blooming industry where you could be making over 100 grand a year. And there is also, you can grow in this industry, like you can go to 250 level, but you got to get started. You got to get started somewhere. And what separates successful people from broke people is that they have more options, and they create the lifestyle which they deserve. And I want to encourage each of you who join us tonight and spend this hour with us, take an action and change your future, and create the lifestyle you deserve. So you can join for $5,999. As I said, I got another surprise, and you got extra 1,000 bonus on this course. So scan this QR code. You can pay the deposit. If you need some payment plan or you have questions, there is a form you can fill out. And one of our career advisors will connect with you, and they will help you to get started. And so don't let anything stop you. So you can scan the QR code and take action today. Start today, so that 6 months down the road, you wouldn't be regretting, that you didn't take that step of action and get started. Because if you wouldn't start right now, you would regret it, because the industry is blooming. And so here's the QR code. Don't miss this opportunity. Few questions I want to answer, and the course is 6 months long. The classes are 3 times a week. It's only 1 hour, and as I said, we keep the group small, so you would be able to get your questions answered. If for some reason it doesn't work out with your schedule, we usually try to do it in the evening, California time. But if you missed it, it doesn't work out, you can always watch the recording and ask the questions from instructor. We do help you with mock interview, coaching, resume building, and you will have experience. So you wouldn't just, learn the theory, but you'll have practical experience, and you don't just get a job, but you will be able to keep this job. So take an action, scan this QR code. If you have any other questions, then please fill this form and we would be able to personally answer them. If you need some payment plan options, you can do that as well. If you want to put a small deposit of $49 and to make sure that you will be included in this group. If you need the Python course, scan this QR code as well. And the other question, Alexei, Dmitry asked us in the chat, I saw, do you need to have a math knowledge to become machine learning engineer? What would you say,
That's
Paul
more
or
that's more
Alexei?
the question for the poll, I think, not for me.
All
Um,
right, Paul, I want you to answer to Dmitry. That's our future students, I hope, who will have a great testimony, but he wants to know. So you tell us, Paul.
so, um, it's true that large components of ML engineering do require some grounding in math. The operation at the core of it is surprisingly mathematically simple. I'll just say that.
I like that.
And
That's a
so, yeah.
good answer. So Paul will help you step by step and you'll be surprised how simple it is. So I want to thank everyone for joining us tonight. Scan this QR code and take action today. Create a lifestyle you deserve and get a dream career. Stop procrastinating. Don't let anything stop you. Just be where you will be having flexibility and the career you like, or you wake up in the morning and you want to go to work and it's actually turns out to be your happy place. So thank you everyone who joined us tonight. Let's start your career in tech. I want to say thank you to Paul and Alexei for being with us. You're an experts and I appreciate you finding time and sharing with us the inside of this blooming industry. So I can't wait to hear more testimonies from our students. So thank you for being with us. Enjoy the rest of your evening, and I hope we'll help you to get started your new career.
Thank you, everybody.
And
I'm stopping recording right
All right.
here.
Thanks.